Hey, welcome. Today we're diving into the hidden science that connects, well, pretty much everything, from the air we breathe to the water we drink. We're going to uncover the chemistry behind some of our biggest environmental challenges, and here's the cool part, discover how that very same science holds the key to fixing them.
So, let's start with a big question. You hear about so many different issues, right? Smog, plastic waste, climate change. It can all feel like this giant, messy pile of separate problems. But what if I told you they were all linked by one single, powerful field of science?
And that science is environmental chemistry. In a nutshell, it's the study of all the chemical reactions happening in our air, our water, and our soil. It's about really understanding what's going on at a molecular level, and, this is the crucial part, using that knowledge to find real solutions. So, let's dive in.
To really get a handle on this, we're going to start with a quick tour of the main battlegrounds, you could say. These are the main types of pollution where all these chemical reactions are playing out right now.
This chart breaks it all down pretty clearly. You've got air pollution from cars and factories, which, leads to things like asthma. You've got chemicals and sewage messing up our water, causing disease. Pesticides and plastics are ruining our soil. And yeah, even noise from traffic is a form of pollution that affects our health. Each one is a huge problem.
But here's the thing that connects them all. Behind every single one of these issues, there's a specific chemical story happening. So to really get it, we need to zoom in a little closer. Let's investigate the chemistry behind three of the biggest environmental villains out there. All right, we're going to unpack the chemistry of global warming, the hole in the ozone layer, and what's literally choking the life from our lakes and rivers.
First up, global warming. Now, the greenhouse effect itself isn't the bad guy. You can see in step 1, it's totally natural. It's like a blanket that keeps the Earth warm and livable. The problem, as you get to in step 2, is us. We're pumping out way too many extra greenhouse gases, which is like throwing another thicker blanket on the planet. It just traps too much heat, and the result is that slow, steady rise in global temperature.
So, who are the main offenders here? Well, you can see a few gases are involved, but look at that huge slice for carbon dioxide, CO2. It's the big one. And most of that comes from burning fossil fuels like coal and oil for energy and to power our cars.
Next up, the ozone layer. This is a wild chemical story. It all starts with these man-made chemicals called CFCs. They used to be in old fridges, spray cans, you name it. Down here, they're super stable, but when they float all the way up into the stratosphere, the sun's radiation blasts them apart. That releases these hyper-reactive chlorine atoms, and a single one of those atoms can act like a chemical Pac-Man, gobbling up thousands and thousands of ozone molecules. It's what thins out our planet's natural sunscreen.
So why does that matter so much? Well, a thinner ozone layer means more of the sun's nasty UV radiation gets through to us, and that has a direct impact on our health. We're talking a higher risk of skin cancer. But it also harms the very bottom of the food chain, everything from crops in the field to tiny life in the ocean.
Okay, our third villain is a process with a tricky name, but a really simple, sad story: eutrophication. It kicks off when extra nutrients, mostly from things like farm fertilizers or even our laundry detergents, wash into a lake. This acts like junk food for algae, causing this huge, explosive growth called an algal bloom. But here's the twist. When all that algae eventually dies and starts to rot, that decomposition process literally sucks all the oxygen out of the water, creating these dead zones where fish just can't breathe.
All right, I know. We've just laid out some pretty big, scary problems. It can feel a little hopeless, but this is exactly where the story takes a turn for the better. Because if chemistry got us into this mess, it's absolutely the key to getting us out. Let's see how.
And the hero in this part of the story is this amazing idea called green chemistry. This isn't just about cleaning up pollution after we've already made it. It's a total redesign of how we do things. It's about being smart from the very beginning, inventing products and processes that are safe right from the get-go.
And this isn't some science fiction fantasy. It's happening right now. Scientists are creating plastics that can actually biodegrade and go back to nature. We have paints that don't fill our homes with toxic fumes. And yes, there are even detergents that are designed specifically not to cause those awful algal blooms. This is chemistry being used for prevention, not just for a cure.
Now, these huge industrial solutions are awesome, but they can feel a little out of our hands, right? So what about us? What part can you and I play in this story every single day?
Well, it starts with this simple but honestly super powerful idea, the 5 R's. It's way more than just recycling. See, it asks us to first refuse stuff we don't need, like a plastic straw. Then reduce what we do use. Reuse and repair what we already have. And only then, as a last resort, recycle what's left over. Each step attacks the problem earlier and earlier. And it doesn't stop there, of course. Every time you flip a light switch off, you're reducing the demand for fossil fuels. Choosing to walk or bike means fewer emissions. Even just sorting your trash the right way makes a huge difference down the line. All these tiny, individual choices really do add up to a massive, collective impact.
Which really brings us back to the core message here today. At their very root, our environmental problems are chemical problems. They're about imbalances that we've accidentally created. But that same incredible power of chemistry also gives us the tools to restore that balance.
So, we'll leave you with this thought. We have the science. The tools are there, we understand the problems, and we are actively creating the solutions. The challenge isn't just the scientific one anymore. It's a question of our will, our choices, and our actions. The real question is, what are we going to choose to do?